Hello students, welcome back, and let's go to the final topic here, section 4, quadratic models. Now all modeling problems are, what can I say, challenging, and they stand alone basically. They can go really deep really quickly, and each is case by case, and it's difficult to find a pattern, and so on and so forth. But I'm going to emphasize the kind of models that have some explicit equations that are given, or something related to geometry so that you can relatively easily get the algebraic expression. Maybe not explicitly given, but you can easily figure those out. This too is geometric. Let's go to an explicit model. The relation, the algebraic relation is given explicitly here. Okay, price P and the quantity X sold is given like this in terms of the relations between one and the other. And what is the revenue? Revenue is price of each item times number of items sold. But then again, in this case, what is X? Negative 5P plus 100. Therefore, this whole thing is negative 5P squared plus 100P. Oops, a typo here, sorry about that. And what did we end up with? We ended up with a quadratic model. This is a quadratic expression. So we're going to have a parabola, and then you can use vertex form to find out h comma k, and that's when we have the maximum revenue. You can do all those. Shall I leave the details to students and move on, or shall we come back and do that a little bit? Okay, stop the playback and do it on your own, and let's check a bit later. Okay, completed or nearly completed? The revenue is price times the items sold, so we get this, and then simplify, we get this kind of expression. Okay, and the revenue must be non-negative. Okay, you cannot have negative revenue. I mean, you'll have to stop somewhere, you see. I mean, negative profit, okay, at least for a while, that's acceptable, but negative revenue does not make any sense. So domain is, this has to be greater than or equal to 0. So we have inequality like this, and solving that inequality, the detail is left to the students, and here goes the domain. And then how about the maximum? Well, vertex, remember the vertex, this graph will be concave up, going up and down, and the vertex, that's what you want. So, p equal to 0, p equal to 20, and then the vertex will take right in the middle here when the price is $10. So revenue at p equals to 10, that's going to be the maximum revenue. And the maximum revenue will be realized at p equals to 10. And then at this price, p equals to 10, we must find the x value. Minus 5p plus 100, and simply plug in x equals to, p equals to 10. You see, negative 5p plus 100, and plug in p equals to 10, and that's what we get. Okay, finally, r of p is 400, find p, all right. So this is r of p, and set it equal to 400. Set this one equal to 400, and that's going to become a quadratic equation, and you can solve for p. So here we go. Oh, wait a minute, is this at least 480? So, okay, not equal to 480, but greater than or equal to at least 480. So it's a quadratic inequality again. Okay. Here, simplify, okay. Change the sign and simplify, eventually simplify like this. And then you can factor further. And then less than or equal to 0, somewhere in the middle, 8 to 12. Okay, so much for the solution. What do you think? Do you think this kind of problem is appropriate for an exam problem? It's a little bit above that level. So I'm going to write this kind of problem in my math lab exercises, but not likely to be in the exams. And one day I may have some projects. In that case, I can write this kind of problems as projects because those can have a little bit higher weight than usual homeworks. But exam problem is conceivable, but a bit too hard. Okay, next. Quadratic models associated to geometry. Now this is going to be a little bit better and I can write this kind of thing in the exam. Now, we do not have explicit algebraic relation, just like this kind of problem gave you, but the computation is going to be much simpler here. All right, what do we want? The area. So 4000 minus 2x here, and then times x, that's going to give me the area. So that's the area there. And then if you simplify, you get that. And what? You want the vertex equation here, okay. And it's going to be half of, right in the middle of x equal to 0 and x equal to 2000 from this, what do you call, the intercept form of the quadratic function. And then that's going to give me 1000. That's h value. So k value is going to be function value at h value, so a of 1000. So here we go, 2 million. Okay, 1000, 1000. Yes, okay, 2 million is correct. Yes, 2 million is correct. Enough time? Okay, looks like we have enough time for another problem there. A Norman window has a shape like this. Okay, we have a rectangle down here and a circle like that. And then what dimension will admit the most light? So we have to maximize the area. So if we express the area as a quadratic expression, then you're looking for the vertex form again. All right? The maximum or minimum, they will all fall in the vertex. Here, the problem's at maximum, so you're going to have concave down and you're going to get vertex for the maximum. Let's see. This picture has too much information. Looks pretty in 3D, but too much information. So let's make it simpler with this kind of planar figure. Okay, x is the height, and r is the radius of this top circular part. Then the width is 2r. Makes sense? Or the diameter, but 2r. So the area is rectangle here, x times 2r, and then area of the half circle here, pi r squared, or half of pi r squared. Okay, all right. Let's see, do we have to find out the perimeter? Oh yeah, perimeter is 20 feet, okay. Okay, perimeter, add them all up. X, so 2x, 2r, and then this. Half of the circumference. Pi r, that's add up to 20, okay. And here I can find out the relationship between x and r. And how about the area? Area of the rectangle plus half of pi r squared, area of this half disk over there. But then again, this x I can solve from the first equation, and then yeah, we solve it and then plug it in. After simplification, we end up with this kind of quadratic expression. And then from here, you can find the, what do you call, the vertex expression. Looks like it's not going to be too bad because I can factor r out. So I'm going to easily get the intercept form. No, I didn't even have to use that. I could simply use H formula and that's about it. Okay, that was easier. Yeah, HK formula, alright. B over 2a, and then negative of b squared minus 4ac over 4a. Yeah, those are simpler. And then plug those values in to find out x as well, and then find out the maximal area. Okay, that's about it. And if you're not comfortable with working these pi's, then feel free to plug in pi and get decimals, but once you want to do some decimal computation, make sure you get enough decimal digits. If you want, say, 2 decimal digits in the end, then the intermediate steps should require at least 4 decimal digits, 2 more. If you want to come down to 4 decimal digits in the end, then work with at least 6 decimal digits in the intermediate steps. That's the usual way to do. Okay, so much for modeling and exercises. As for Norman window, again, it's a bit too hard. Okay for project, yeah, but for exam preparation, not very good, I have to say. Okay, that's where I'm gonna stop. Good luck, everybody.